Welcome. So in this video, I will talking about a very famous set called Vatali set. So which is a non-measurable set. So to be more precise, that people call it non-measurable means that it's not a bag measurable. Okay, so in this video, I will first create a set, and the second is that I will give a detail why it's not proof is non-measurable by using the proof of contradiction. And before I start, that hope you guys can subscribe to my channel. Okay. Okay, so that's quickly starting our journey. So let me just find write down the goal. So the goal is that we want to quick find what, right? We just try to find a set called V, which is the subset of R, such that V is non-measurable. So non-measurable as the back measure. Okay. So basically, so you can view the back measure of the V. Just try to find the length of the V. Okay. Right. So there's the back measure called lambda in the R. Right. So basically, if you take the 0, 1, then it just give you a length. Right. And there is obviously that this lambda has the just easy interpretation is as a length. Okay. So how to create this? Okay. So the key idea is very so the creation is very astonishing. Is that you just take a rational number, right? So rational, if you see as an addition as a group, that rational number is a normal subgroup of real numbers. So what I'm writing about, so it's normal subgroup of the real numbers. Okay, so once we know this, then we can define R quotient Q, right? So which R quotient Q as a group means that X plus Q for all X belongs to R. Okay. So one can view that's just this is a subset of R. Okay. So for each, right? So for each equivalence class, so equivalent class. So there are infinite equivalent class, right? Because one knows that 0 plus Q is the same as a half plus Q is the same as 1/3 plus Q, right? But also 1 over square root of 2 plus Q is different from 0 plus Q, right? Because 1 over square root of 2 is irrational, right? So for each equivalent class, there's a representative, right? So this is a key idea. Let's say call it X, right? So the idea is that so first I take all the repeat. Okay, so the idea is that how should I say this? Okay, so now I create a set called V. So called set V. So V to be what? So V to be let's say a set. Let's say X belongs to 0 and 1. And okay, so that's okay. So I should say, so V is defined to be X from 0 and 1, right? And such that there's a condition such that there's a representative of R mod Q. There's exactly one representative. There is exactly one representative of R mod Q. Okay, so what it means is that for each, right? So basically, you can find a many representative. So as I say, right? But for each 0, 1, right? So for each representative, let's say you have a representative for some class, right? Then you can shift this representative into 0 or 1, right? Because you can always minus Q, right? So for each representative, you can always find a shift. So let's say for example, 3 is a representative, right? 3 is a representative of 3 plus Q, right? And you can move 3 as 2 plus Q, same as 1 plus Q, and it becomes 0 plus Q. So I can choose 0, right? So 3 can map to 0 in 0, 1, right? And for each, let's say maybe a square root of 2, and square root 2 can map to square root of minus 1, right? Because this is a 0.4 something, 0.14. So, okay. So I collect all of its X, all of these representative. and I make a assumption that such that there's exactly one representative of R mod Q, right? So so for example, the half plus Q is the same as 0 plus Q, right? But I delete 1 over 2, so I delete half because half is already inside this V. Sorry, half is already, so 0. If I choose 0, then I cannot choose a half. Okay. So okay. So hope is clear is that this V such that there is exactly one representative of R mod Q. So all of the equivalent class have the representative, and I always choose that representative in 0 or 1, and I collect all of its representative. Okay. Yeah, so this is the difficult part to understand this set. So once you understand the construction, then everything will be easy. Okay, so such that there's okay. So the idea is that right. So the first thing is that V is a subset of 0, 1, right? By construction, and also V is uncountable. This is obviously right because there are infinite irrational number. Okay, so there are infinite irrational, so V is uncountable. Okay, so that's a right. So that's the proof, right? The second is that I proof is not measurable. Okay, so second, V is not measurable. And the reason is that suppose it is, right? Suppose it is, right? So that means people can define a lambda v. So lambda v will be a number, right? Will be a number, and also v is a subset of 0, 1, right? So the idea is that lambda v should be less or equal to 1 or something like this, right? Okay, so so that's the proof is that so suppose it is measurable, then I can take. Then we know that rational number is countable, right? So that's I define y defined to be q intersection the all rational number intersection minus 1 to 1, and I can label this by let's say q1, q2, right? Keep going because this guy is this y is countable set, right? So this is countable, right? Because q is countable. Okay, now I can define a vk to be v plus qk. So basically it's x plus qk for all x in v, right? So basically I just add k, I add qk. Okay. So idea is that if I collect all the vk, and then what is the region for this vk, right? So the first is that right, if I collect all the vk, right? So vk start from -1 to from 1, right? So if I think 1, right? Then so v can move to 1, right? And the v can also v can also move to the previous. Okay, so so the vk, the maximum value for vk is you can only move -1, right? So then this is -1. Okay, and then you can only move, right? You can only move up to 1, right? So if you start from 1, then you move to 1 is basically constrained by this. Okay, and what is the left bound, right? So the obvious left bound should be 0, right? But actually the left bound can be bound by 0, 1, right? And the reason is that so to prove this, you need to think that if there's some number here, that number must be represented by k, right? But this is the definition for vk, right? Because if you choose any number in the 0, 1, then you can find a qk, right? You can find a if you choose any number, right? So if I want to prove this statement, then I need to show that any number in 0, 1 can find some vk, can find some qk, right? Such that it falls into some vk. And this is easy, right? Because for let's say for any number x belongs to 0, 1, right? But by definition that there's a representative, right? So that means I can always find qk, right? Such that it falls into vk, right? Because I can shift, I can add that representative. So basically, this qk, right, will make this vk much powerful. So to make to cover this 0, 1 in a closed interval. Okay, so if that's the case that by activity, then this length is 1, right? Or larger than the lambda vk, k from 1, maybe from 1 to infinity, and less than 3, right? Because of the length. But the problem is that lambda vk can only has two possibility. One is 0, right? If it's 0, then it's impossible because it's larger than 1, right? If lambda vk is larger than 1, then it will always blows up. So this is a contradiction that no such lambda, right? And the reason is what we also know use is that so there's a detail that I didn't say. So lambda vk is just lambda v, right? So actually I should say lambda v, right? So there's no k here. So idea is that the sum of there are infinite lambda v, some infinite of them, then greater or equal to 1 or less than 3, which is impossible. Okay, and why this is true, right? Because the back measure is invariant on the translation. So if you just add something, right? If you just add qk at something, then it will become then the volume will be the same. Okay, so that's the construction and the detailed proof that why it is. So I think the difficulty is this part, right? So and the definition of v. So I hope you understand what I'm saying. Okay, so or if you don't understand, then you can just think carefully and see and say. If you don't understand anything, you just type below it. Okay, and be sure to subscribe to my channel. I will see you guys in the next videos.